Details about SPMachCycle. We'll start at the top, network 1, with the verify on bit. So when Merlin receives a message that commands it to do something, it'll reply back that it got the message just fine. But that's not necessarily an indication that Merlin was able to process that message. With verification on, shortly after sending the initial message and receiving a reply back, another message is sent asking Merlin to send back the value in the parameter you're trying to update. Now the two have to match in order for the message to pass. That short time delay is governed by the value in pull time. Now, during testing, we set that value to 4, which equates to 200 milliseconds. If you don't send any value to pull time and the function block detects that it's equal to 0, it will automatically set pull time value to 6, which equates to a 300 millisecond delay. Discrete pat select on. So Merlin has 4 inputs. They can be used in one of 2 different ways. One way is for pattern select. If you have Merlin set up to use the inputs as pattern select, then you want to make sure you keep this bit set true all the time, and the pattern that Merlin loads is governed by the value in pat select integer. If you want to use those Merlin inputs as arguments to an input tool in the Merlin pattern, then leave this bit set false, and you can control those inputs with the laser control.user in 0, 1, 2, and 3 bits. Merlin parks on pattern load. So if you have all 3 of these conditions, one is Merlin controls motion through a BM470. The other condition is Merlin is set up to park after a pattern load. And the third condition is you're actually sending p-type messages to upload or to load patterns in Merlin. Then you want to make sure you keep this bit set true. What this does is it will prevent errant timeout failures while Merlin is parking. Pull request. At times you want to send a message to Merlin just to ask it to return back a value in a certain parameter. Say you want to know the name of the pattern that's currently loaded. So you would set the pull request bit and then initiate a p-type message. And Merlin will reply back with the name of the pattern that's currently loaded. And you'll find that response in the TSP series laser control.pull reply. Fail reason. If for some reason you should have a message failure, you can look in tuser.failReason, have an indication of why the message failed. So I'm going to use this network as an example. This is a typical structure for sending a message. In this case, we're sending variable text to line 1 in the Merlin pattern, and we want to populate line 1 with whatever's in tuser.variableText. Now you'll see the sample cycle bits in here. You'll want to replace the sample cycle stuff with your cycle bits. Another important thing to note is before you can initiate a message, you need to make sure that the idle bit is always true. And then you want to make sure you branch around that idle bit with the message bit. So there are two ways to tell Merlin to start print. One way is with a G-type message, and the other way is with a discrete bit. In this case, we've used this SPMachCycle1200 bit to toggle back and forth between the two while testing. You'll want to select which direction you want to go and modify this rung accordingly. Continue after pause. So in our mock cycle here, the Merlin pattern would encounter a pause for go tool. When we saw that happen, we would simulate, say, capturing an image, calculating an offset, a rotation offset, and then sending that rotation to Merlin before telling Merlin to carry on with the pattern. In that case, you want to use the continue after pause to break out of the pause tool and move on with the pattern. The type 1 message. Type 1 message is a particular type of pull message where you feed a line number that you want to ask information from in the Merlin pattern, and Merlin will reply back with the data that's on that line. Now, if there's a flag, message flag, such as $J for Julian date, then that message flag will be parsed out, and as part of the reply will be the actual Julian date that Merlin will print. And that concludes this discussion of TSP machine cycle.